In this video, we will be talking about Mars rover's Riemann sums and definite integrals. The Spirit rover landed on Mars in 2004 and was active until 2010. It was powered by solar cells. Unfortunately, storms on Mars deposited dust on the solar panels, which reduced the rover's ability to generate power over the course of its 6 years of operation. As a rover travels across the Martian surface, it kicks up dust, which accumulates on its solar cells. The amount of dust that it kicks up depends on the composition of the surface. A rockier surface kicks up less dust than a softer area. Imagine that scientists are planning to send another rover to Mars and want to know how long this rover might last before too much dust accumulates. They have mapped out a 100-kilometer path for the rover to follow and have collected satellite data about the composition of the Martian surface at various points along the route. Here is a table that shows the composition at the various points along the route with NASA's estimate of how much dust would accumulate on the solar cells per kilometer traveled over the surface. So we know that when the rover has accumulated 275 milligrams of sand on its solar cells, it will not be able to produce enough power to continue. So we ask the question, if the rover travels along this path, will the rover accumulate too much dust? So, what we are going to concentrate on is multiplying constant rates times amounts of change in distances. And this will give us approximations to the amount of dust that has accumulated over that distance. So the general strategy is to break our distance into intervals where we know enough information to do some type of estimation. So one of the first things is to recognize that the data given is in rates. And these are given in the amount of dust per kilometer. So to approximate how much dust accumulates over any interval, we need to multiply that given rate by a distance traveled. So we are going to treat the rate as being constant over any amount of change in distance. So we'll assume that the entire distance over the first 10 kilometers is very rocky. So dust will accumulate at a rate of 1 milligram for every kilometer the rover travels. This constant rate tells us that if we accumulate dust at a constant rate of 1 milligram per kilometer for a total of 10 kilometers, then we can multiply this rate of 1 milligram per kilometer by 10 kilometers and get an estimate to the amount of dust accumulated of 10 milligrams. So now we can repeat this process for each of these intervals of distance. So now let's look at the second interval. For this second interval from 10 to 30 kilometers, we are going to assume that for the entire interval, the surface is moderately rocky. So we're going to assume that the rate of accumulation of the amount of dust per distance traveled is 1.5 milligrams per kilometer over the entire interval. So we are assuming that this rate is constant for the entire trip from 10 kilometers to 30 kilometers. So for the second interval, the rover is going to accumulate 20 kilometers multiplied by 1.5 milligrams per kilometer, or 30 milligrams of dust total. So repeating this process for every interval, we get this table of data. So this 10 that I've highlighted represents the dust accumulated from 0 kilometers to 10 kilometers. The 30 that I just highlighted represents the amount of dust accumulated from 10 to 30 kilometers. And finally, the 60 represents the amount of dust accumulated from 90 to 100 kilometers. This now brings us to the end of the rover's trip. So now that we've considered each interval separately, we can combine them by adding up the amounts of dust accumulated over each interval. So if we add up all the dust accumulated, we are going to get 260 milligrams of dust. We previously said that 275 milligrams of dust would reduce power to the rover, so it looks like our rover is going to be just fine. So now let's talk about a general technique. This will be a general technique for estimating the total amount of dust accumulated by the rover. So we're going to break this up into two steps. For the first step, we're going to multiply the rate of accumulation by the distance traveled by the rover over each interval. For our second step, we're going to take all of these estimates for each interval and we are going to add them. Adding them will give us a total accumulation for the dust. So this process has a name. It is called creating a Riemann sum. The method of estimating the total amount of dust accumulated is simply one example of a Riemann sum. And what we were really doing was adding a product of quantities. And in our case, this was a rate times a change in distance. And really, you can use a Riemann sum whenever you're trying to find a total amount of something accumulated. So we can always use this process if our goal is to find a total accumulation. And it's really going to have the same kind of structure, where we're going to be adding up a bunch of things that are of the form a multiplication of a rate times some sort of change in some quantity, in our case a change in distance.